Hello and welcome to our Frontier Precision webinar on Trimble Unmanned Aerial Systems. Before we begin, we're convinced that Trimble is dedicated to doing this process the right way, making sure that they and we operate UAS responsibly and within the guidelines of the Federal Aviation Administration. First, let's start with what is aerial imaging. Aerial imaging is simply airborne data collection. This can be done by either manned or unmanned aircraft. Typically, the imaging sensor payload would be your standard RGB camera, a near-infrared camera, an infrared camera, or a thermal camera. What is UAS? An unmanned aerial vehicle, or UAV, commonly known as a drone, is an aircraft without a human pilot on board. The flight is controlled either autonomously or by computers in the vehicle, or under the remote control of a pilot on the ground or in another vehicle. The term Unmanned Aircraft System, or UAS, emphasizes the importance of other elements beyond just the aircraft itself. A typical UAS consists of the following: the unmanned aircraft, a control system such as a ground control station, some type of control link or specialized data link, and then any other necessary related support equipment. Some of the key benefits with Trimble UAS are that it is very safe. It enables a remote measurement of rugged, hazardous, hard to reach, or unhealthy areas without risking harm to people. It is also efficient, meaning we have the ability to capture data and generate deliverables with more detail, and also faster than often achievable with terrestrial measurement. It's very rapid, where we can plan, fly, and process a project in a matter of a few days. It's versatile, meaning one technology can serve numerous projects and applications. And it's also very economic, meaning that it's reasonably low cost to purchase. Also, there are rentals and professional services available to bring the cost down for end users. So let's first talk about the legal requirements for UAS. We'll go over the public agencies and how they require a COA, the exemption 333 for private corporations, and then also at this time who can purchase these systems today. If you're a public agency that want to operate under a COA, the rules for this have not changed. Public agencies are still able to file for a COA. Public agencies with COAs remain eligible to purchase UAS systems per the existing regulations, and we can also provide information and guidelines regarding this process. Now let's talk about the FAA's 333 exemption. By law, any aircraft operation in the national airspace requires a certified and registered aircraft, a licensed pilot, and operational approval from the FAA. This provides operators who wish to pursue safe and legal entry into the national airspace a competitive advantage in the UAS marketplace, thus discouraging illegal operations and improving safety. There are several methods for users to access UAS flights. The first is to file for their own 333 exemption and purchase their own systems. There are also methods where they can leverage Frontier Precision's 333 exemption that permits us to operate commercial flights in the United States. This exemption permits Frontier Precision to operate controlled UAS flights under a COA that we obtain from the FAA. Pricing for these UAS services are determined based on the project scope and customer requirements. Who is eligible to purchase today? As of today, we can only sell the UAS systems to customers that can provide us proof that a public COA or a Section 333 exemption has been applied for with the FAA. Also, what is required on the job site when flights are taking place? Each flight will need a COA or a Certificate of Authorization approved by the FAA for the job site. Current 333 exemption holders have a blanket COA for 400 feet and under for Class G airspace. Additional COAs may need to be applied for operations that are taking place in airspace other than Class G. Each flight will also need a pilot in command and a visual observer in order to operate. A licensed pilot will need to be on site to act as the pilot in command. The pilot in command must file a NOTAM or a notice to airmen prior to the operations. And operators of the Trimble UX5, UX5HP, or the ZX5 systems must be Trimble certified remote pilots. Users must stay in compliance with the rules set forth in their COAs or 333 exemptions. Now let's look at the current Trimble UAS portfolio. As of now, there are two fixed-wing solutions, the Trimble UX5 and the Trimble UX5HP, which stands for High Precision, And then we have the multi-rotor solution called the Trimble ZX5. There are different solutions for different applications. Typically with the fixed wing solutions, we are going to map larger open areas, or if we're looking for very efficient data capture over large areas. There's also the vertical takeoff or multi-rotor solutions, which work great for smaller obstructed areas, horizontal and vertical mapping, and they can also be used for visual inspections. First, let's take a look at the Trimble UX5. The Trimble UX5 is operated using an automated flight plan created in Trimble Access Aerial Imaging, which is loaded on the Trimble tablets. The software also has a heavy focus on safety and legality, meaning there are several steps in a pre-flight checklist that must be completed and verified before operations can commence. The system has a GPS-only receiver and has roughly a 50-minute endurance on the battery. The Trimble UX5 has a cruise speed of 50 miles an hour and can handle up to 40-mile-an-hour winds and light rain. The communication range is roughly 3 miles, and typically we want to use ground-controlled targets to tie it into our local coordinate system. The Trimble UX5 utilizes a Sony Alpha 5100 camera. This is a 24-megapixel camera with an APS-C sensor type. Also included with the Sony Alpha 5100 camera is a high-quality Voigtlander lens. This lens has a fixed focus and a 15mm focal length. There is no zoom with this lens, which means the sharpness of the image has a 1-to-1 relationship with the flight height. It's also important to note with the cameras that it is not all about the megapixels. Typically with cameras, the larger the sensor type, the more light that is captured, and the better the image quality will be. The APS-C sensor in the Sony Alpha 5100 camera is the largest that you can go before a full-frame 35mm camera is needed. These cameras are typically too bulky and large to fit in UAS systems. Here's an example of an image captured with the Alpha 5100 camera flown at a height of 75 meters above the ground. Now let's discuss the Trimble UX5 HP. The Trimble UX5 HP is very similar to the UX5. It also is controlled with an automated flight plan using the Trimble Access Aerial Imaging software with the same focus on safety. This system has a GNSS receiver, which means we're capturing more higher quality GPS data during our flight. The flight endurance is roughly 40 minutes, and the cruise speed is roughly 53 miles per hour. The UX5 HP can handle up to a 34-mile-an-hour wind and light rain with a communications range of roughly 3 miles. With this system, ground control is not needed. The Trimble UX5 is able to capture high-precision image locations in flight using post-process kinematic to achieve accurate image positions. This allows us to eliminate ground control and map the most inaccessible and difficult areas with ease. The UX5 HP also utilizes the Sony Alpha 7R camera. This camera is a 36-megapixel full-frame sensor type, which means it has 2.3 times more sensor service than the UX5's Alpha 5100 camera. The Alpha 7R is the lightest and most compact camera in its class. It also delivers high ortho quality and point cloud density. Going back to our sensor size graph, we can see that the Alpha 7R is a full-frame 35mm camera, which is small and light enough to fit within the UX5 HP body. Also, with the UX5 HP, we offer some flexibility with different lenses. Voigtlander lenses with the fixed and high-quality optics are also available in the following versions. There's a 15mm version, which at 75 meters above ground level gives us a ground sample distance or a pixel size in our image of 2.4 centimeters. There's a 25mm lens, which allows us to get down to a 1.5 centimeter ground sample distance, and then the 35mm lens, which gets us down to a 1 centimeter ground sample distance at 75 meters. Here's an example of the F1 circuit in Barcelona, flown at 100 meters above ground level with a 1.4 centimeter ground sample distance or pixel size with the UX5 HP. Notice as we zoom in, we can still see the crispness of the image, and then we can zoom in even further to see the detail of people actually walking on the racetrack. Looking at the components, we have the UX5 or the UX5 HP. Inside the case, you can see in the case we have batteries, chargers, additional propellers and wingtips. We also have the tablet which runs the system, and then we have a separate case with the launcher and the components. So what's the difference in the accuracy and performance when we compare the UX5 using ground control points and the UX5 HP using just the GNSS? If we look at the minimum ground sample distance with the UX5, we're getting down to 2 centimeters. With the UX5 HP, we're getting down to 1 centimeter. This gives us roughly our maximum points per square meter of 200 with the UX5 and all the way up to approximately 1,000 points per square meter with the UX5 HP. And then if we equate that to points per flight, the UX5 is going to give us up to 200 million points per flight, and the UX5 HP will get us up to 500 million points per flight when we process our point clouds. Now let's take a look at the Trimble ZX5. The ZX5 is a multi-rotor solution that allows us to capture aerial images as well as video. This system is designed for horizontal and vertical mapping applications, as well as asset inspection for infrastructure, building facades, construction, plants, and so on. We see it as a complementary tool to the UX5 or the UX5 HP. Looking at the components of the Trimble ZX5, we obviously have the airframe, and with the airframe we have the gimbal and the sensor, the battery packs, the ground control stations, TBC Advanced Photogrammetry Module software or UAS master to process the data, as well as the flight planning software for our automated flight plans. Looking at the system specifications, the ZX5 utilizes a multi-rotor G4 flight controller. It has a light carbon fiber structure, foldable arms and legs for easy transport, and up to 20-minute flight time per mission. The ZX5 utilizes the Olympus EPL7 16.1 megapixel camera, a brushless motorized gimbal, the Jetty DS14 radio control station, which gives us up to 1,000 meters of range. Additionally, we can add a live view 5.8 gigahertz video option. The system is wind stable up to 22 miles per hour and has a maximum airspeed of 18.5 miles per hour, as well as a maximum takeoff weight of 11 pounds. This would include the camera and the batteries. With this system, it's possible to get the ground sample distance down to 1 millimeter. Looking at the gimbal with the camera, the number 1 on the image is the gimbal power control cable and connector. Number 2 is the mount to the copter, where we actually attach the gimbal to the ZX5 airframe. Number 3 is the brushless gimbal motor. Number 4 is our Olympus EPL7 camera with the Panasonic pancake lens. And number 5 is the camera mounting plate, which is also part of the gimbal. Looking at the remote control devices, we can utilize the 2A 2.4 gigahertz with telemetry and data display with the smaller of the two systems, or we can go up to the video inspection module, which allows 2A 2.4 gigahertz with telemetry data display, full manual non-GPS flight controls, and a 7-inch monitor, as well as a 5.8 gigahertz video transmission. Now let's take a look at some of the types of deliverables we can produce with these systems. There are many avenues that the sensor data can be taken down for deliverables. Typically, the most common deliverables are going to be individual still images, orthomosaic photos, raster digital surface model or digital terrain model images, colorized point clouds, and site and/or structure videos. This data can then be used for other deliverables and maps such as surface models, contour maps, and so on. Here's an example of an individual still image. Here would be an example of an orthomosaic image. This is an image that is created when multiple still images are stitched together. Then we have a raster digital elevation model image. Then we can take that and create a colorized point cloud. And from the point cloud, we can then create surfaces and contour maps. So this is just a brief overview of the Trimble UAS systems. If you would like more information or have additional questions, please contact your local Frontier Precision sales representative or visit www.frontierprecision.com. Thank you.